All right, we are right on time with my GPS clock here. Thank you all for joining. If you're watching this live, thank you for taking time out of your day, either morning, evening, night, wherever you're at. This is the November installment of the PASS High Availability and Disaster Recovery Virtual Chapter. This month, we're lucky enough to have Glenn Berry to do a presentation on High Availability and Disaster Recovery 101. It's one of those, there's a lot of new benefits and new things that we can do for HA and DR, but it's not a new topic. It's not a glamorous topic, but it's one that's absolutely critical, and you as a DBA need to really know this stuff. So we're going to take about 30 seconds here, run through some past community news, and then I'll turn this over to Glenn. Okay. First of all, I really hope you were all able to join in on the PASS Summit last week. I had an absolute blast. It was a great conference. If you were not able to join in on that, go check it out still. You should be able to sign up, see the recordings. It was just a great time, a lot of phenomenal content. As part of all this, the PASS Pro membership is out. There's a lot of great content out there. It's really a good, solid program designed to really help you further your career, and as a result, help your organization. So go take a good look at it if you can. We're not the only virtual group out there. There's actually 20 virtual chapters out there. These are phenomenal groups. There's tons of incredible content out there. And if you're not able to catch them during the live sessions, these are all recorded. They're all uploaded to the PASS TV YouTube channel. So go check these out. Great content. Especially with this year, if you're looking for a new career, or more importantly, if you're looking to hire, get onto the PASS Career Center. There's some great information out there. This is a great spot to go do this. It's a wonderful community as well. So go check that out. Connect with PASS. Chances are you already know how to get in touch with them, but they're on all the major social media channels. Sign up for a free membership if you don't already have one. And now I'm going to turn this over to Glenn Berry for High Availability and Disaster Recovery 101. There we go.
All right. So this is obviously my deck from the Group Buy conference, but my name's Glenn Berry, and here's my Yay Me slide. And the important thing about this is my email address and also my Twitter handle. If you have any questions that I don't answer, please reach out. And I know how to brew beer. I'm a home brewer. I've been doing it for about 5 years. I make 5-gallon batches of beer. That's what some of my beer looks like. And that's some of the medals that I've won, although the contests have sort of been put on hold this past year, unfortunately. But anyways, it's a very fun hobby that I really enjoy. And what we're going to actually talk about is HADA DR 101. And we're going to have this agenda. We're going to talk about the main causes of downtime and data loss, and how do you go about planning a high availability strategy, and some things that are built into the product that you can use to try to get HADR, and then talk about DR strategies. And just, yeah, that's sort of it. I'm not going to show you how to do anything really here. We're going to just talk about the high level concepts. It's a 101 class. So what does HA actually mean? It means that something is available to be used as expected, no matter what happens, is really in a nutshell. So in our context, it's usually a database or a group of databases behind a web server or an app server. And you want to make sure that that thing is available to service transactions no matter what happens. And whatever it is you're trying to protect, you're protecting it with various technologies and techniques to prevent it from being unavailable. So that's it in a nutshell. And what is this something? It might be just one table in a database that you're worried about. And if that was the case, which is not very frequent, you could just protect that with replication or something that protects the entire database. More likely, it's one database or a group of databases you want to protect. So if it's a group of databases that are part of an application, an availability group could be used. Or maybe you want to protect an entire server with a whole bunch of databases on it. So you could protect it with traditional failover clustering. Or maybe you're trying to protect an entire data center. So something like SAN replication would help you protect if you lost the entire data center. And I want to break it down into the two main causes of downtime and data loss. So you've got planned downtime and unplanned downtime, and they're quite different, and they get counted against you differently at a lot of different organizations. So common reasons for planned downtime is that Maybe you're doing some sort of maintenance on your database. So if you're stuck on SQL Server Standard Edition or you don't have online index operations, just creating an index on a really large table might be a reason to take an outage because it's going to lock the table otherwise. An Enterprise Edition doesn't have that issue. So that's one reason a lot of organizations will spring for Enterprise Edition for that one feature. And with SQL Server 2017 and newer, you've got resumable index operations, which help you a little bit more. Another reason you might take planned downtime is if you know you've got to go and delete hundreds of millions or billions of rows from a table, and you don't want to have it take a long time, you could just take an outage and take care of it in a batch operation, one big delete, but that's going to lock up your table. So that's one reason. But really the most frequent reason people take planned downtime is some sort of an upgrade or maintenance on SQL Server or the operating system. So if you're installing Windows updates or a SQL Server cumulative update, or you're updating drivers or firmware on the server itself. And that's another reason to have an HA topology in place, because when you're doing that sort of thing, you can do a rolling upgrade process to minimize your downtime. And people who just have standalone instances with no HA at all, they have to go in and apply the update and usually bounce the server and take a long outage. And if you've got any kind of HA in place, you can roll through and do that and have a series of brief outages. So that makes your overall uptime statistics look better. So unplanned downtime, you might lose an entire data center, depending on especially where you live in the world or in the country. So if you have a hurricane come in or a fire or extended power loss, or lose your network connectivity because of a backhoe took out a cable, things like that could take an entire data center offline. And if you think that's something that could happen to you, you might want to have a secondary data center. Another thing that is not as common as it used to be is losing a server. PC-based hardware is a lot more reliable than it used to be. And if you take the proper precautions with redundant components, it's even less likely you're going to lose an entire server. And then you might have problems with your I/O subsystem. So just losing one or more drives or a RAID controller or having a bug in your drivers for your I/O subsystem, things like that are fairly frequent still. But by far the most frequent reason to have unplanned downtime is human error. So somebody just makes a mistake. They think they're connected to development and they're connected to production, and they drop a table or delete a bunch of data in a table. And that kind of thing is the most common reason in my experience to have unplanned downtime. And there's things you can do to help protect against that. But anyways, what a lot of people do, unfortunately, when they're thinking about HA, when they finally get around to thinking about it, is they just pick the new shiny feature. So availability groups are relatively new and they're newer than most of these other technologies. So a lot of people just say, oh, we should use availability groups. And it might not be the best solution for you. And that's not the way you should be thinking about it anyways. I don't have anything against availability groups, but what you should be doing is thinking about your recovery point objective, RPO, and your recovery time objective, RTO. And what RPO means in just plain English is how much data can we afford to lose in terms of time before it's a big deal for the business. And of course, if you go to the business and say, how much data can you afford to lose before it's going to be a problem? They're usually going to say none. We can't lose any data or it would be the end of the world. And when you have that conversation with them, first of all, it's really important you do have that conversation because otherwise they're going to assume that their RPO is zero. Because hey, you're using SQL Server and you have Glenn Berry as your DBA and you have RAID 5 for your data, right? So everything's perfectly safe. You'll never ever lose anything. And that's not true. And so you need to go back to them and say, look, it's almost impossible to get zero RPO with SQL Server, but we can get as close as possible to that. And here's a plan and a budget for how to meet that objective. And quite often when they see what it might cost to get as close to zero as possible, they might back off and say, hey, wait a minute, we can't afford to spend that kind of money. How about if we said 5 minutes is okay or 10 minutes is okay? But the point is you've got to go through this and get them to agree that, okay, 5 minutes or 10 minutes is our RPO that we're trying to meet. So that's how you're going to make a lot of decisions and build your architecture based on that RPO that they've signed off on. And the recovery time objective is how long does it take to recover if certain bad things happen? So if you lost an entire server, how long would it take you to recover from that? If you lost your entire data center, how long would it take you to recover from that? If somebody dropped a table in production, how long would it take to recover? And so you try to come up with how long would it take to recover from these common things we think might happen, and see, is that okay? Could we be down for 8 hours, or would that make us go out of business? And try to come up with a plan that the business agrees on, that, okay, we're trying to hit 4 hours RTO for this kind of failure and 1 hour for this failure, and so on. Otherwise, they're going to assume that your RTO is like 5 minutes. Doesn't matter what happens, we can be back in 5 minutes. So it's really important you go through this before you start building stuff and buying hardware and deciding what technology to use. So another thing that's really important is, excuse me, your allowable downtime. And you might have heard of the term, 4 nines availability and 5 nines availability. And this is a table that kind of shows what that means in real life. So it's pretty easy with SQL Server, even with a standalone instance with no HA or DR whatsoever, to get 90% availability. But if you start going further down this table and you get to 4 nines and 5 nines, especially 5 nines, that means you're only allowed about 5.5 minutes roughly downtime per year to hit 5 nines. And it's important that you have it established. Does this mean unplanned downtime or all downtime if you're being measured against these kind of metrics? But it's really hard to do 5 nines because just a few failovers back and forth with an availability group is going to start to burn through that. And if you're using failover clustering, it'll happen even faster. So just some context there. All right, so SQL Server 2019 has several different HA related technologies. And the first two here aren't actually technologies, they're just things that are really important for HADR and just in general for SQL Server, as opposed to, say, a web server. So we're going to go through all of these. I'm not going to read them off, but we'll briefly go through each one of these and talk about why they're important. So the first thing, which is more important than any of the rest of this talk, is backup and restore methods. So the first thing you need to do is make sure you understand the different recovery models and pick the right one for what you're trying to do. And most of these HADR technologies require you to be in full recovery model at all times. And so if you're in the habit of switching to bulk log and back to full, or you want to run in simple, you're not going to be able to do that with a lot of these technologies. But you need to make sure you pick the right one to meet your RPO goals. And usually that means full. So full recovery model is probably what you're going to want to use if you're worried about this sort of stuff. And then you got to have a backup strategy that's going to let you meet that RPO. So how often you take full backups, whether or not you take differentials, and how often you take log backups is really important. And differential backups are actually very useful, but a lot of people don't even use them. And they help you tighten your RTO. If you're having to restore a full backup sequence and you've got a differential that lets you skip a whole bunch of log restores, that can make you come back online more quickly. And then thinking about backup compression and using backup checksums, and then using the backup tuning options will make your backups and restores, in many cases, go much more quickly, which is important here. And then the other part that's even more important is recovery strategy. A lot of people take lots of backups, but they never test restoring. And that's the only way you can really know for sure that your backup is good, is by restoring it. All the things that you can otherwise do, like restore, verify, header only, things like that, don't guarantee that the backup is good. You actually have to restore it. And I've run into so many companies and heard so many stories about companies who had backups, they thought, and then something terrible happened to the production database, and they go to try to restore their backups, and they find out that they're no good. And then it's game over, essentially. So make sure that you are actually thinking about recovery and actually doing restores on your important databases, especially. So instant file initialization is very important when you're doing a restore. And then whether or not you use backup compression can be a big difference, especially if you've got relatively slow storage, and keeping your VLF counts under control, because that's going to reduce the recovery time portion of a database restore, and that can make a big difference in some cases. So backup tuning options, you've got the buffer count and block size and max transfer size parameters or options that you can use. And depending on your data and your infrastructure, sometimes these can make a huge difference in how long it takes to take a backup. And it used to be if you were using backup compression with transparent database encryption, you had to set the max transfer size greater than 64K in order to make those two play well together. But you don't have to do that anymore in SQL Server 2019 CU5. They got rid of that requirement. But the point is, you should do some experiments with your larger databases that take a long time to run a backup on and see if playing with these parameters helps or not. I've seen it make a pretty big difference. All right, another thing that I like to do, a lot of my clients have done, is have a secondary restore server. So once you take your nightly backup, for example, you could have an automated process go and take that backup file and try to restore it on another server to make sure that it actually will restore. And then once you've done that, you can run dbcc check db on it, on that secondary server. And if it fails there or has problems there, you can rerun it again in production. But by doing that, that takes some of the dbcc workload off of your main production server. And you know for sure that your backups are good because you're restoring them every night on this secondary server. And that's a lot better situation than the poor DBA who never ever restores the backup because, hey, it takes too long and I have no place to do it. And you just hope that it's good. So don't let that happen to you. So Bill Baker was a distinguished engineer who worked at Microsoft. And he came up with this basic idea that I sort of stole and changed a little bit. But he was talking about the difference between scaling up and scaling out. And scaling up is a lot more common for database servers. And what this means is if you've got a 2-socket server and it becomes overloaded, you would move to a 4-socket server. And you would not get double the performance, by the way, if you did that. But anyways, that was scaling up. And when you're scaling up and you're dealing with a database server or just dealing with the database server in general, you think of your server like a pet. You know, you give it a name, and when it gets sick, you nurse it back to health, and you know it's really important. It's a mission critical asset. And when scaling out, like you do with web servers, the servers are more like cattle, and you just give them numbers, and when they get sick, you shoot them. And what this really means is, you know, a lot of the hyperscalers, when a server has a problem, they don't even bother to troubleshoot it. They just yank it out of the rack and throw it on a pallet and sell it on eBay. They don't even try to fix it. But this mentality isn't a big difference. And what you need to do with the database server for on-premises is you've got to treat it more like a pet instead of cattle. So make sure you spend that a little bit of extra money on redundant components and make sure you configure it for redundancy. Then actually test your component and connectivity redundancy on that server. So we'll talk more about what that means, but it's important that you do this because you don't want to have a failover because you lost a hard drive or you lost a power supply. So component redundancy is just PC-based servers have redundant hot swap components for most important things. And spending that extra $100 or $200 on a second power supply, for example, might avoid an unplanned failover in the middle of the day that makes you go down for, say, a minute. And maybe that minute loses so much business or causes so much heartache among your customers that it's totally worth it to spend $100 or $200 to prevent that from happening. And you want to try to go through your hardware for your database server and eliminate all the single points of failure that you can. So multiple power supplies and separate circuits, multiple network ports plugged into separate switches, having the appropriate level of RAID, so RAID 10 instead of RAID 5, for example, and having hot swappable components, and then having some cold spares. So if you've got 4 Dell R740 servers in a cage, maybe you've got one extra power supply that fits an R740, and maybe you've got one extra hard drive or SSD that fits those servers. So if you lose one, you can immediately replace it with your cold spare and then get the replacements shipped out from Dell as soon as possible. Little things like that make your infrastructure more robust. So component redundancy versus HADR, all these things that we're going to talk about have some failover duration. So a traditional failover cluster instance has to move the cluster resources and start SQL Server on the new node, and that takes some time, typically 60 to 90 seconds. And then availability groups and database mirroring, all they're doing is just a database property change and then replaying the unrestored portion of whatever got sent over. So usually the failover is a lot more quick with that, 10, 15 seconds typically. Log shipping is a manual failover, but you can script it out to semi-automate it. So avoiding whatever that failover duration is by having more robust hardware is a good idea. That's a lot of people don't do anymore, unfortunately. And so you want to take advantage of every option you can to make that database server more robust, because look at the cost of SQL Server licenses versus spending $500 more on a server really is a no-brainer, I think. So HADR effects on hardware store choices. You want to make sure that you understand does your HADR architecture you're going to pick or create any extra workload on your primary server. So if you're using traditional failover cluster instances or log shipping, there's no extra workload. Availability groups and database mirroring do create some extra workload because they're having to pick up everything and send it over to the different replicas. And especially if you have a synchronous replica, that's going to have an effect on the application performance because you're waiting on the secondary replica to get committed. And then transactional replication also creates some extra workload because of the log reader agent. And if you've got a local distribution database, that's extra workload that might affect your primary workload. And also you want to understand, can your secondary hardware keep up with your primary hardware in normal operation? Because what a lot of people do is they'll take their old hardware and make that a secondary and get newer hardware for their primary. And if the old hardware is really old and really slow, it's going to struggle to keep up, especially if you're doing synchronous operations with that secondary. And you also want to make sure that if you ever had to fail over to the secondary, can it handle the workload? Or is it just so old and so slow that you're going to really be hating life if you ever had to fail over it to it? So HADR effects on storage choices. Traditional failover clustering requires some form of shared storage, and that's usually a SAN, but you can use storage spaces direct, or you can use third-party products like Sios. And if you are using traditional failover clustering, strongly consider moving your TempDB to local node storage instead of having it on the shared storage, because you're usually going to get much better performance, and you'll move the TempDB workload off of the shared storage. Of course, not everybody uses TempDB that much, but if it's an issue, that's one cheap, easy way to improve it. And then all the other methods we're going to talk about can use any kind of storage that you want. So don't let your infrastructure people bully you into using shared storage if you can use other kinds of storage for better performance for SQL Server. All right, and then one other thing you want to try to avoid doing is don't use a single SAN for both sides of your HA solution. I see a lot of people doing that because SANs do fail no matter what the salespeople want to tell you. All right, it's also important you pick the right RAID level for your SLA. And RAID's not a substitute for a backup and restore plan. Don't let anybody ever tell you that. And it's not a substitute for an effective HADR strategy. And you want to make sure that you have an appropriate RAID level, because all it's doing is reducing the chance of downtime due to the loss of one or more drives. And RAID 10 and RAID 50 are a lot more resilient than RAID 5. And really, you want to try to avoid RAID 5 if you're worried about HADR, because you can only lose one drive in an array before the array goes down. And having more drives in an array increases the statistical chance that one will fail. And so RAID 5 is inexpensive, but it has a lot of issues. Of course, another reason is parity-based RAID, and it hurts your write performance quite a bit. And that's another reason to have hot spares in a RAID array and then have cold spares in the enclosure. If you ever lose one, you can replace it as soon as possible before you lose another one. All right, so now Windows failover clustering. That's kind of the oldest technology that we're going to talk about here. It's been around for a long time and a lot of people are very familiar with it. And it just means you've got multiple machines that are called nodes. And the easiest way to do this is just install one instance of SQL Server as a failover instance on those two nodes, for example. And this used to be called active passive clustering. And of course, if you say that now, Alan Hurt will get very upset with you. But anyways, it's one way of doing this, and it requires shared storage, which is a single point of failure. And again, usually people use SANs for that, but there's alternatives for that. And this gives you instance level high availability. So all the databases and all the objects on the instance, like the system databases and the logins and agent jobs and linked servers, everything is automatically protected. And if you add more databases later or make changes, everything just is automatically protected. You don't have to worry about maintaining all the replicas and keeping them in sync with the primary. So it's really good for shops that don't have a full-time DBA, or if you don't have any experience whatsoever with availability groups. A lot of people, oh, failover clustering is old-fashioned, I'm not going to use that, but it's a good choice for a lot of people. And the downside to failover clustering is the failover is longer, because again, you've got to move the cluster resources and then start SQL Server on the new node. And so that can be an issue. And of course, you also have the shared storage as a single point of failure. But beyond that, it's a good choice. And I like it for a lot of smaller organizations. So here's what it looks like. 2 nodes with shared storage, and SQL Server is running on one node or the other. And whichever node that SQL Server is running on owns the cluster resources. And you have a virtual IP that the applications connect to, and they don't care which node you're actually running on. And it's once you get it set up, it's just dirt simple to administer. So don't discount it just because it's old-fashioned. All right, TempDB to local storage. On SQL Server 2012 and newer, you can move TempDB off of the shared storage and put it on one of those nodes. And if you use very fast flash NAND-based storage, or even better, Intel Optane storage, you're going to get much, much better performance than any SAN can give you for TempDB. But if you propose this, prepared, your infrastructure people are probably going to fight you on it. No, we don't want to do that. We love our SAN. And if you're going to do this, make sure that your local storage is really fast. And you might not need to do this. If you're barely using TempDB at all, you probably don't need to worry about this. But if you're an OLTP app, or you're using RCSI, for example, and you're just hammering TempDB and it's a bottleneck for you, this is a cheap, easy way to really improve the situation. And I really, really like the Intel Optane DCP4800X. It's been around for about 3 years now. It's a first generation Optane storage, and they're not that expensive. The 375 gigabyte model is about $1,000 roughly. And you can have one of those on each one of your nodes and have TempDB running there, and it's going to just smoke your SAN for latency, for example. So here's a little bit more about Intel Optane storage. It comes in different form factors, but the most common one is an add-in card that fits in one of your PCIe slots. And it has to have a PCI 3 X4 slot, and it uses NVMe, and it has 3 different sizes you can buy it in. And the nice thing about this, you can run this even if you're not doing failover clustering. If you just want faster TempDB performance on a local machine, this works with any version, any edition of SQL Server. It's independent of SQL Server, and it has better write endurance and better write performance and lower latency than any kind of NAND flash. It's not NAND, it's using phase change memory. And it doesn't lose performance as the drive gets close to being filled up like NAND storage does. So it's a great little product. So that's my Intel commercial, but that's what it looks like right there. And anyways, moving on, here's a summary of the HA features by edition that we're going to go through and talk about. But Enterprise Edition has everything. So every single one of these features is supported in Enterprise Edition. Standard Edition has almost all of them since SQL Server 2016 SP1. There's only a few restrictions. And then if you're using Express Edition, you can't really do much of anything besides be a witness for database mirroring or be a replication subscriber. So anyways, availability groups is the next thing. And that was introduced in SQL Server 2012 as sort of a replacement for database mirroring. And it lets you have one or more databases that fail over together is the key thing about this. And it requires, at least on older versions, Windows Failover Cluster feature to be installed, but you don't have to have shared storage. A lot of people don't understand that. and it was Enterprise Edition only until SQL Server 2016. And all the databases have to use the full recovery model at all times if you're using availability groups, if they're going to be in an availability group. And an availability database is just a database that's in an AG, and you've got the primary database that's your read-write copy, excuse me. And then a secondary database is your read-only or non-readable copy. It doesn't have to be read-only. And you can have up to 4 replicas in 2012 and up to 8 on newer versions, but most people don't have that many replicas. And one thing it was sold as when it was first rolled out is that you could offload read-only activity to the read-only replicas. And that sounded really awesome when I first heard about it. And it works, but the key thing is you can't make any schema changes on those read-only replicas, so no extra indexes. Because a lot of people would use transactional replication for reporting and add a bunch of indexes to the subscriber so they could run reporting queries, and you can't do that with availability groups, unfortunately. So here's kind of a crude diagram of what availability group looks like. You've got 3 copies of the data in this case, and you've got 3 different machines, and they all have SQL Server installed just normally. It's not a failover installation. And one of them is the primary, that's SQL Prod 1. And then the other 2 are secondary replicas. And you can have them be synchronous or asynchronous replicas. And it's just important you understand that if you have more and more replicas, you're going to have more and more copies of your data, and you're going to need more disk space. And each one of these could be local storage, or they could be SAN storage. It's totally up to you. You don't have to use shared storage for any of this. All right, basic availability groups, that was added in SQL Server 2016 Standard Edition, so they could also use availability groups, but they have a lot of restrictions. And it's really more like database mirroring because you have only one database can be in a basic availability group. So if you've got 10 databases, you're going to have 10 basic availability groups. And each one of those only has one replica. You don't get multiple replicas like regular availability groups. But one nice thing about this compared to database mirroring is you can use synchronous or asynchronous commits for this. And that gives you a little bit more flexibility because with database mirroring and standard edition, you can only use synchronous instead of asynchronous. And that can be a big deal. So again, one replica, and you can't read the secondary replica. You can't run backups on the secondary replica. And only one database is in the availability group. And you can't upgrade this. So if you're running standard edition and you do an edition upgrade to enterprise edition, you have to tear down all your basic availability groups and then rebuild them as regular availability groups. And then if you're running enterprise edition, you can't use these, but you wouldn't want to. If you're on enterprise edition, you want to use regular availability groups. All right, so database mirroring came out back in SQL Server 2005, and it was deprecated in 2012, but that doesn't mean it doesn't work anymore. It still works perfectly well in SQL Server 2019, and it's still a good solution in some scenarios because I think it's easier to set up than availability groups are. And if you got experience with mirroring and it's working well for you, don't let Microsoft scare you. Oh no, you shouldn't use this anymore. You know, it still works. There's no kill switch. I'm not going to turn it off. They were threatening to take it out of the product in SQL Server 2017, but they chickened out at the last minute, and I don't think they're ever going to remove it. So if it's working for you, go ahead and use it. And again, this is similar to availability groups in a lot of ways. Your databases have to be in full recovery model at all times. And you've got a principal database, that's your read-write copy, and a mirror database on a separate instance. And that mirror database isn't accessible. The only thing you can do with the mirror database, if you really want to, but it's not a good idea, is you can take a snapshot of it, and then you can run reports against the snapshot. And that was only in Enterprise Edition until SQL Server 2016. But anyways, you can have synchronous mirroring or asynchronous mirroring. And if you want automatic failover, you've got to use synchronous mirroring and have a witness instance to have automatic failover. And if you wanted asynchronous, you had to have Enterprise Edition. And the reason you might want asynchronous is maybe your data center, your secondary data center is far away. Or maybe you've got older, slower hardware and storage for your secondary. or your mirror, I should say. And that was common reasons to use asynchronous mirroring, and you can't do that with standard edition. So again, just one database with one mirror, and the mirror is not accessible. So here's what database mirroring looks like. Your principal is on the left, and it's got its own copy of the data, and then the mirror is on the right with its own copy of the data, and then that witness instance is just there to form a quorum, and it's not doing anything besides that. So you can run it on Express Edition, and this is tried and true technology, and a lot of people have experience with it. All right, transactional replication. This is just a set of technologies that let you have copies of data. So you've got a publisher, that's your read-write copy, and then you can have subscribers, multiple subscribers to that. And they can be used for different purposes. Usually the most common scenario is reporting, but you can also use it for HA if you replicate the entire database, which is definitely possible. So that source database is a publisher, and then destination is a subscriber. You have something called a log reader agent that picks up all the write activity from the publisher and then stores that in a distribution database. And then you can either have a pull or a push subscription that's pulling that data out of the distribution database, and it eventually ends up on the subscriber. And by eventually, hopefully this is in a few seconds, but it can be longer. And replication works pretty well, but if you're using replication, be prepared to fix it fairly often, because it often has little problems that need to go in and fix. So be aware of that. But the nice thing about transactional replications, once you got that publisher going, it's pretty easy to add more subscribers, and they can be in different locations. So that's kind of nice. And then the other advantage of this is you can add all sorts of extra indexes to a subscriber and use it for reporting, and take that reporting workload off of your main OLTP database. All right, SQL Server Replication has been around a long time, and some people think, oh, that's old-fashioned, I'm not going to use that. But Microsoft invested quite a bit in SQL Server 2017 in cumulative updates, by the way, to make replication work better. So they made it so that the distribution database takes care of itself better without you having to manually go and take care of it. And it lets you put the distribution database in an availability group, because that was one big problem before, that you couldn't protect these databases very well unless you used failover clusters. So the point here is that if you're on a newer version of SQL Server, it's very important to stay up to date on cumulative updates. Don't be one of those shops that never ever updates from the RTM build, because you're missing out not just on bug fixes, but on feature updates and improvements. All right, peer-to-peer replication is something that hardly anybody uses, to be honest, but it's a form of transactional replication that lets you have multiple writable copies of the database. And it's enterprise edition only. And so the common scenario they talk about is, let's say you've got an office in London and one in New York and one in Tokyo, and each one of these want a writable copy of the database. Well, you can do that with peer-to-peer replication. And so as the data is being changed in each one of those copies, it's sent around to the other two, and they eventually, hopefully within a few seconds, synchronize. And so the data is the same in all three. But you've got to be careful with that, because quite often you've got to go in and make some application or database schema changes to make this work. So a common scenario is identity columns. If you've got an identity column for something like order ID, and you want to make sure you can set it up that way so that the identity column ranges don't overlap. So that's one way you might have to go in and make a change. What some people will do is go and change that to something like a GUID, which I think is a very bad idea. But the point is, you might have to make some changes to make this work. All right, log shipping. Log shipping is another technology that a lot of people discount because it's old-fashioned and simple, but it gives you database level protection, and you can have multiple copies of the database in multiple locations. Again, all the databases have to be in full recovery model at all times, and you don't get any automatic failover for this. A lot of people say, well, it's just for DR, but it's better than nothing for HA. You know, if you just have a standalone instance, setting up log shipping to an old server is better than nothing. And the weakness with log shipping is some data loss is possible, because all it's really doing is automating taking log backups and then moving those log backups somewhere else and then restoring them. And you can have multiple places that those are being restored to. And again, what can happen here is if your main server dies before the last log backup was sent over and restored, you could lose all the data since the last log backup that did get restored. So you're going to have a bigger RPO window because of that if this is all you have, but it's much better than nothing. And it can also protect you against user error because you could set up one of your log shipping copies with a 4-hour or an 8-hour delay. So if somebody drops a table, if they come to you quickly enough, you could go get that table from the log ship copy, and that might be quicker than restoring a full backup of a huge database. And another nice thing about log shipping is you can layer it on top of most of these other technologies. So if you're using availability groups for local HA, you could log ship to a secondary data center or log ship to another server in your main data center with a delay to protect you against user error. And another nice thing about this, it doesn't add any extra performance overhead because hopefully you're already taking log backups. So that's all you're doing is taking log backups and then moving it around and restoring it somewhere else. All right, so here's what log shipping looks like. And you've got 3 servers in this case, and the primary is your read-write copy, and then the other 2, you can set them up so they become available for reads, but then they can't have any more log backups restored to them. So it's kind of a kludgy thing if you want to try to use your secondaries for reporting, and I don't really advise that you do that. All right, database snapshots is another thing that people use. So you can run a database snapshot in SQL Server, and it just is a pointer to what the database looked like at that exact point in time. And then the snapshot file tracks what happens to it after that. And that snapshot file is going to get bigger as time goes on and cause performance problems. But some people will use snapshots for things like, let's say you're pushing out new code to your main database. Some people will take a snapshot right before they do it. And then if they needed to, they could revert back to that snapshot, for example. And it was Enterprise Edition only until SQL Server 2016 SP1. So this is another thing that you can put in place to try to make your overall HADR story better. All right, so here's the different feature differences between these things I've talked about, whether instance level or database level, and what recovery model they require, and then how fast the failover time is, relatively speaking. So this is kind of a handy chart. So planning a disaster recovery strategy. What you want to do is have your most experienced people write the disaster recovery plan, but then you want to have your junior people actually test it and try to execute it, because quite often your more experienced people are not going to be on duty over a holiday or on a weekend or late at night. And no matter what else you do, make sure you've got a really good backup and restore plan, because if everything else fails, but you've got good database backups, you can eventually come back online. And you've got to go and talk to the business and find out in advance, what is most important, which databases and which applications are most important that we should be trying to work on restoring first, instead of trying to figure it out during the disaster. And, as I said, the junior people are the ones who are probably going to be doing this. And you want to try to write your DR plan in such a way that a non-DBA could follow it. So you can't just say something like restore the database from backups. That's not going to be good enough even for a DBA. You want to have more information than that. Where are the backups stored? And what is the naming standard? And here's a set of scripts for how you would start the restore sequence. And there's ways to automate this with, DBA tools, for example. So you want to try to have that all in place so that your boss or some server admin who doesn't even know SQL Server could follow the plan and have some information in there. What if the script fails? Call Glenn. Well, Glenn's not available. Have information in there so if something easily predictable happens, you could get around that. And you also want to think about the human factors in a disaster. If a hurricane hits Florida, do you think your employees are going to be worried about getting your website online or worried about their families and their house? So what some companies will do that live where hurricanes come in all the time, they'll have a secondary data center somewhere far inland, and they'll put their people on a plane and their families. And they'll put them on a plane and fly them to the secondary data center. So then the employees know their families are safe, and they can concentrate on their job as getting back online and running the business from the secondary data center. And whatever plan you come up with, you should try to test it, because every time you execute it, you're going to find, oh, we forgot about that. And you hopefully add to the plan and make it better over time. So other things you need to think about with DR planning is think about the problems that might happen depending what kind of disaster occurred. So if it was a hurricane, are your servers physically damaged and ruined? Is the SAN damaged? What would you do if that happened? Can you go out and get another SAN, or go to Micro Center and buy a server? What would you do? What if there's no power at the data center? And what if the data center is gone? Where the offsite backups were stored at, and how can you get them back? What if your DBAs are all gone on vacation or something? Does anybody else have any clue about how to restore the database and get everything going again? Other things that are really important to think about in advance is if things start going poorly, like let's say you've got 2 data centers and something's wrong in your main data center, how long do you spend troubleshooting of the main data center before you decide to fail over? And who makes that call? Because if this is not decided in advance, you're going to get in trouble no matter what. So if you spend an hour troubleshooting and then you decide to fail over and you've been down for an hour, somebody's going to be upset. Why do we spend all that money on the second data center and you didn't even fail over to it? And on the other side, if you decide to fail over after 5 minutes and then you figure out that, oh yeah, it was something simple we could have fixed in 10 minutes and you've already failed over, and coming back is painful, that can get you in trouble. So it needs to be decided in advance. And who makes the call? And you also need to think about, a war story I have is one time we had a big problem at NewsGator many years ago, and people kept coming up to my cube saying, what's going on? What's going on? Can we help? And they were really interrupting me. So my boss finally put a whiteboard in front of my cube saying, Glenn knows there's a problem. He's working on it. Leave him alone. And that really helped. But having things in place so that everybody knows what they're supposed to be doing, they're not just running around with no plan, it's really, really helpful. And there needs to be somebody who's in command of the DR effort who can settle any kind of disputes about resources or priorities. And you also need to have it in place who you're going to be notifying as you're going through and doing everything. And it's also important to have some people from the business that are available to confirm that the applications are working 100% after you've done your DR. Because as a DBA, you probably know the very basics. Oh, I can log on to this application and it seems like it works. And it's kind of a smoke test, but there's probably Alice in accounting who has something that's really important for payroll that you have no clue about, and you think everything is fine, but it's actually not. So some business people have to go in and check it out thoroughly to make sure that there's no problem that you don't know about. So HADR testing, it's really important that you do as much testing as you can if you're doing a brand new greenfield HADR architecture before you go into production. So do all the things that you can think about. Go and just pull out a drive or two from a server, or unplug a server, or unplug a network cable and see what happens. Does it fail over like you expect, or does everything just crash and burn? And then do other things like drop a table or truncate a table. And this sort of testing is called chaos monkey testing. And it's important that you do everything you can think of, but then have somebody else do something that you didn't think of. What we used to do at Avalara is we would go and get a receptionist from the main office and bring them into the data center and tell them, okay, go unplug something or flip a switch and let's see what happens. And sometimes you'll figure out, hey, wait a minute, we never ever thought that could happen. And you'll find a weakness in your infrastructure. And then you want to find out how long does it take you to do a bare metal install of SQL Server or stand up a VM, or how long does it take you to restore your biggest database from backups? You better know that, because first thing that's going to ever happen if you ever have to do it, your boss and their boss is going to be saying, okay, how long is it going to take until we're back? And if you don't have any clue whatsoever, that's going to make you look bad and make your day a lot more stressful than it already is. So if you go through and do all this and you figure out, okay, we agreed that we could have RTO of 4 hours for this particular failure, and we tried it and we just can't do it, make sure the business knows about that. because maybe you can get more resources or get them to agree to give you a bigger window, or maybe you can just think of something smarter to get around that. All right, so just to summarize here, HADR is a lot more than just picking your favorite technology or feature. A lot of people make that mistake. I see it all the time. Oh, we're going to use availability groups because it's the best thing you can use. It might not be the best thing depending on your skill set, for example. And make sure that you and the business understand your RPO and RTO SLA requirements, and they've signed off on that. And then make sure the business understands your budget and your infrastructure limitation. They might want a secondary data center, but you've only got $10,000 in your budget to stand up a second data center. That's probably not realistic. And no matter what else, if you don't remember anything else from this talk, make sure you've got a good backup restore strategy, because that's going to save the day if everything else fails. You might be down for a long, long time, but if you can restore your backups, you'll eventually come back online. And make sure you know the backups are good by restoring them on a regular basis. And then keep in mind that you can combine these different features. So you could have local failover clustering with log shipping, for example, or a local availability group with log shipping on top of that. All right, so I've got a few references here. These are on this page are mostly Pluralsight courses that I've authored on how to set up log shipping and how to set up database mirroring and how to properly install and configure SQL Server 2016. The last one is a really old white paper, but it covers the basic principles with nice pictures and really good explanations very, very well, so I recommend it. So anyways, there you go in English and German. Thank you for coming to this, and if anybody has any questions, I can take them now, or you can think of them later and send them to me.
Awesome, thanks, Glenn. That's great stuff. We do have a couple of questions in the queue. The first one is whether or not the slide deck will be available for download. I can actually partially answer that. We do record all these sessions and make them available after the fact. So the easiest way to find just a full recording of this session would be to go to hadr.pass.org, and under the archives section, there'd be recordings to the YouTube channel. And additionally, Glenn, if you wanted us to publish the slides, you could email them to David, and he could also put a link.
Yeah, I'll do that. I usually make a PDF version of it, and I'll send that to David, and you guys can post it or distribute it however you want to.
Awesome, thanks. Next question is, can a enterprise AG log ship to SQL standard target?
Yeah, I don't see any reason why not. Yeah, I think that would work just fine. I mean, normally people have the same edition, but yeah, I think that would work. So I just haven't actually done it, but I don't see why it wouldn't, because it used to be a problem in the past that maybe you were doing something that was enterprise edition only, like data compression. But if you're on SQL Server 2016 or newer, you don't have that problem. All the programmability things like that are supported in standard edition. So unless you were using something like transparent database encryption wasn't in standard edition until 2019, for example. But as long as you're not doing something enterprise only that's not supported in your version of standard, that shouldn't be a problem.
Mm-hmm. Yeah, that makes sense. I think it used to be a lot more scary, like you say, before 2016, when that list was pretty long.
Yeah, there's hardly anything on the list anymore, though.
And we may have actually run through the questions already.
Oh, that's okay.
Yeah, any last minute? No, I usually figure a couple questions is a good sign. That means the material was solid and well presented. Any last minute questions coming in?
Well, thanks for all of you who showed up and listened.
We did get one last one.
Okay.
Will database encryption make any difference in this topic? So I'm assuming that's triggered by the TDE discussion we're having or mentioned.
Well, it could, because if you've got TDE on your primary or main data center and you're trying to restore that in a recovery scenario, you got to take that into account. You got to make sure you've got the master key and everything set up to be able to restore it. Anything that's encrypted with TDE, otherwise you're going to be unhappy there.
Cool. Well, and I'd like to thank you again, Glenn, for giving this talk, and thank everyone who took time to watch this session.
Yeah, again, thanks to everybody, and the recording will be online, and then if you have any questions later, just reach out to me.
Okay. Awesome. Thank you.
Okay. All right. Thanks a lot.